This is Prithviraj. Today, my topic is on carbon and its compounds. This is a very important and a very interesting chapter for CBSE 10th class science, chapter number 4. Under this topic, we are going to cover the introduction part, introduction to this chapter, bonding in carbon, that is covalent bond. Next, versatile nature of carbon, chemical properties of carbon compounds, important carbon compounds, soaps and detergents. This all content need to be covered under this topic. So before going depth of this topic, let us first know about the element that is carbon. Now, if you see the symbol for carbon, that is nothing, capital C. And the atom number, it is 6, atomic mass 12. So, 6 number of electrons, 6 number of protons, 6 number of neutrons I can find. Whereas, if you try to locate its position in the periodic table, it is placed in the 14th group, coming under P block. It's a non-metal, and the electronic configuration of carbon will be 2, 4. So that means K shell contains 2 electrons and L shell, which is the outermost shell, contains 4 electrons. That is called valence electrons. Now let's switch on to our first subtopic, that is introduction. We all know carbon, when it is present in atmosphere, it is present with a percentage of 0.03% in the form of carbon dioxide. Whereas the percentage of carbon in earth crust, it is only 0.02 in the form of minerals like carbonates, bicarbonates, coal and petroleum. So togetherly I can say only 0.05%, which is a very small quantity. Although it is a very small quantity, but we can find the carbon is of immense significance, not only in the elemental form, but also in combined form. And that's the reason we need to study the properties of carbon and its compounds. We know compounds, correct? Compounds classified into 2 types, that I can say organic and inorganic. We have to know organic compounds. Organic compounds are those compounds where carbon will serve as the main element, or you can say it serves as the backbone element of this type of compounds. Whereas inorganic compounds are those compounds where you cannot find carbon as the main element. For example, organic CH4, which is called methane, you can see carbon is the main element or the backbone element. Whereas the inorganic element, example will be HCl, you cannot find carbon here. Now, in order to understand the properties of carbon and its compound, as I told you just now, we should have to know about the bonding part. What type of bonding it can exist in carbon and its compounds. So that is bonding. We can find covalent bond. Now covalent bond is what? It formed due to mutual sharing of electrons. due to mutual sharing of electrons between two non-metals, I can say. So covalent bond always exists in carbon and its compound. We can see that one in the noble gas configuration of carbon. How the configuration of carbon could not able to help out the carbon to go for ionic bonding. It has to go with a mutual sharing of electron to have a covalent bonding. Let's see. If you see carbon here, he records 4 electron to complete its nearest configuration of the element. That's element is here nothing, neon. So neon got 2,8. So in order to complete that nearest configuration of the noble gas, he records 4 more electron. Now imagine, suppose if he accepts 4 electron to form carbon neon. In this case, the carbon will get 10 electrons and it has only 6 proton. Now it is a very difficult for the nucleus to hold up with 6 proton for the 10 electrons. Similar way, if he loses 4 electron, he will have only 2 electrons and 6 proton, and it is difficult now also for the nucleus to hold up. And moreover, more energy is required to take out 4 electrons in its outermost shell. In order to avoid or overcome this problem, carbon has to ultimately share the valence electron with the neighboring elements. For example, like methane. In this way, the carbon can form octet configuration, can get it, and hydrogen also can complete its duplet configuration. In order to understand more about bonding, let us take some few examples. Some homoatomic molecules, few, and few heteroatomic molecules like H2, N2, O2. These are homoatomic molecules, and methane and water, these are heteroatomic molecules. Here you can see 2 different elements are getting involved. Here only similar type or same type of elements are getting involved to have a bonding, covalent bonding. So hydrogen. Hydrogen, when he approaches, one hydrogen atom approaches towards the other one. So one hydrogen atom have only one valence electron, I can say. So he will share with the other valence electron of the other hydrogen atom. Because if you see the configuration of hydrogen, it has got only one electron in its K shell. So he needs one more valence electron, I can say, to complete its duplet configuration. So in order to complete that, he will share the valence electron with the other hydrogen atom. So this type of bonding, I can say, is a non-polar covalent bonding or bond. It is a non-polar covalent bond. There is no difference in the charge. Charge separation is nothing. Whereas in case of your water, here you can see the oxygen shares 1 electron with each neighboring hydrogen atom, and other rest, the 4 electrons or 2 pairs of valence electron will remain unshared. That is called as a lone pair of electrons. So these are called lone pair. Whereas these pair are called shared pair. But the bonding when it happens between oxygen and the hydrogens, slightly got a negative charge, delta negative, and slightly got a delta positive. Because as oxygen is more electron negative as compared to hydrogen, it will try to pull the electron slightly towards the oxygen. And because of that, this bond is called polar covalent bond. So this is all about the bonding part, how it happens in covalent compounds, I can say, or carbon and its compounds. Now, we should have to now think, is there any kind of speciality is there in the carbon? Is there any kind of special, or you can say unique nature of carbon is there which make it completely unique? Yes, there is some special property which exists only with the carbon. So that is called versatile nature of carbon. And because of two property, it is very unique. Let's see what are they. One is catenation. That is, catenation means self-linking ability. Carbon got a very good tendency, having a capacity to link up with other carbon atom up to 12. So it can link up with many carbons and form straight chains. It can form branch chains. It can also form cyclic structures. Similar way, the second property, which is called tetravalency. Carbon has got a tendency to show its tetravalent nature, by which carbon can exist by forming single bonds with other neighboring carbons, or it can also form double bonds with other carbons, or it can also form a triple bond with the neighboring carbons. Because of this two above property, I can say, or I can conclude here my subtopic, that millions of organic compounds can exist in our nature, which makes this living organism exist in our earth. So this is all about my topic, that is carbon and its compounds.